Recent advancements in large language models, or LLMs, have transformed the way we approach complex reasoning tasks, enabling the creation of general-purpose autonomous agents. These models, like GPT-4, Llama, and PaLM, excel in areas such as problem-solving, knowledge-intensive work, and even interacting with dynamic environments like video games or web navigation. As researchers Neerchos Potamitis and Akhil Arora from Aarhus University point out in their paper, this progress has led to a boom in prompt-based reasoning frameworks, which help LLMs think through problems more effectively. At the heart of many of these frameworks are iterative reasoning strategies. These methods involve the model refining its outputs over multiple steps by evaluating its own performance. For example, approaches like self-refine and reflection require the LLM to generate verbalized feedback. Essentially, the model has to explain its mistakes and suggest corrections. This self-evaluation can improve accuracy, but it comes at a high cost. The paper highlights that these strategies add significant computational complexity. The model not only solves the problem but also spends resources recognizing errors and articulating fixes, which increases the overall expense, especially as the context window grows with each iteration. To illustrate, the authors reference RAFA, a state-of-the-art refinement strategy using GPT-4. On a benchmark task called the Game of 24, which only has 100 examples, RAFA costs around $600 just for processing that test set. This makes iterative refinement methods not only time-consuming but also financially prohibitive for widespread use. In response to these challenges, Potamitis and Aurora introduce a simpler alternative called Retrials without feedback. This concept is straightforward. If the LLM identifies an incorrect answer, it simply tries again from scratch without any explicit self-reflection or verbalized critique. There's no need for the model to generate lengthy explanations of what went wrong. It just attempts the problem anew until it gets it right or reaches a predefined limit on attempts, based on computational budget. The beauty of this approach lies in its simplicity. Unlike reflection, which relies on the model producing feedback narratives, retrials keep things minimal. The paper explains that this method can be easily integrated into existing reasoning frameworks, such as chain-of-thought prompting, where the model breaks down problems step by step. When the authors tested retrials, their results were surprising. They found that basic methods enhanced with retrials often outperformed more sophisticated techniques. For instance, a simple chain-of-thought approach with retrials beat out tree of thoughts, which involves exploring multiple reasoning paths like branches on a tree, and even reflection itself. This suggests that the extra layers of complexity in those advanced frameworks don't always deliver proportional benefits, especially when retrials provide multiple chances to succeed. The paper delves into why this might be the case. In reasoning tasks, LLMs can sometimes arrive at the correct answer through sheer repetition or slight variations in their attempts, without needing to analyze their failures. By avoiding the overhead of verbalized feedback, retrials reduce costs while maintaining or even improving performance. The authors conducted experiments across various domains, showing consistent advantages in efficiency. Furthermore, this work challenges a common assumption in the field, that more intricate strategies inherently lead to better outcomes. Potamitis and Aurora argue that the added computational burden of self-reflective methods might not justify the marginal gains, particularly in scenarios where resources are limited. They point out that as LLMs continue to improve, simpler mechanisms like retrials could be all that's needed to push performance further. To put this in context, the paper references earlier studies on LLMs, such as those by Brown and colleagues in 2020, which laid the groundwork for these models' reasoning capabilities. It also ties into ongoing research on prompt engineering, where techniques like those from Wei and colleagues in 2022 have become foundational. In their analysis, the authors emphasize that retrials without feedback align well with real-world applications. For example, in autonomous agents that perform tasks like web navigation or tool use, retrying a failed attempt quickly could be more practical than pausing for self-analysis. This could make LLMs more reliable in time-sensitive or resource-constrained environments. The paper also touches on potential limitations. While retrials are efficient, they might not work as well for problems that require deep insight or where errors stem from fundamental misunderstandings rather than minor slips. Still, the overall message is optimistic. By focusing on efficiency, we can enhance LLM reasoning without overcomplicating the process. Ultimately, through their experiments and comparisons, Potomitis and Aurora raise a provocative question about the future of LLM development. If retrials can deliver strong results with less effort, does that mean we should rethink how we build and optimize these models? Their findings encourage the research community to prioritize cost-effective strategies, potentially leading to more accessible and scalable AI systems. This insight could influence how engineers design prompts and frameworks moving forward, making advanced reasoning more attainable for everyday applications.